Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is IZZATI binti Mama ARIF, and I'm gonna be presenting about my study on the effect of electrical and thermal conductivity to a spot welded S235 steel sheet by simulation. So my supervisor name is IR Dr. EMRI Abdul Rahman, followed by my co-supervisor Professor IR Dr. YUPITER HP MANURUNG. So the contents that I'm gonna be explaining in this presentation are including the project summary, the introduction, literature review, problem statement, methodology, and also the expected result. So moving on to the project summary. So basically what I'm doing is study the effect of the electrical and thermal conductivity to the metal sheet using the resistance spot welding model. So resistance spot welding is one of the way to join thin workpieces which the thickness is less than 3.5 mm. So there are many parameters that need to be considered when using the resistance spot welding. The software used to do the finite element analysis is MSC mark method. The result gained by simulate the model according to the custom dimension and parameter of electrode and steel sheet. So there are certain temperature that is needed to ensure the formation of the weld nugget is built up nicely. Next, in this introduction, I will explain about two things. That is, what is resistance spot welding and what is its parameters. Resistance spot welding is an efficient joining method commonly used in the automotive industry, but it also widely used in other industries such as manufacturing and also aerospace industry. So this technique has been invented around more than 100 years ago, but receiving less attention until recently. So almost all studies has been focusing on the arc welding because resistance spot welding is a complicated process which involves interaction between the electrical, mechanical, metallurgical, and also thermal. So the process of this resistance spot welding is by joining one or more point by heat generated from the resistance to the flow of electric current through the workpieces. It is also joined under the pressure by a pair of electrodes. As mentioned before, resistance spot welding is a complicated technique. But because of why? Because of this welding consists of 6 parameters that need to be consistently monitored, which are weld current, hold time, size of the electrode contacted with the surface, the squeeze time, the weld time, and also the force given by the electrode. So this resistance spot welding also depends on the electrical and thermal conductivity. So the first literature review is on the electrical conductivity. So when there is a current pass through a series of electrical or thermal resistance, it will generate heat. So heat transfer coefficient at the workpiece or the electrode has an extremely significant influence on the nugget formation. So what is meant by conductivity? It is an electric charge or heat that can pass through a material, whereas the resistance is the opposition to the flow of current in an electric circuit. So when the electrical energy is converted to the thermal energy, it will dissipate heat. So the heat is very important in this resistance spot welding. So moving on to the second literature review is on contact conductivity. So resistance spot welding is a process where materials are joined together under pressure and electric current forming a weld nugget which then will be solidified. So contact conductivity it varies and depends on the various variables such as the sheet thickness, the welding time, the current density between the surface, and these variables will affect the heat generation. So, contact pressure distribution at the surfaces of materials may relate with the temperature history, the electric force, coefficient of friction, and also the properties of the materials. So, the reason why this research is being done because of the booming of the automotive industries. So if you look at the problem statement, auto body assembly requires between 7,000 and 12,000 welding spots depending on the size of the vehicles. So this means that one vehicle consists of 7,000 to 12,000 welding spots. So in order to cope with the demand, heavy-duty electronic device and components in motor vehicles is increasing. Then this make the method used in the bonding the component had reached to the limits of their possibilities. So a new process and a new information about the resistance spot welding is needed to cope with the automotive industry. So for the objective, first of all, the objective of this study is to analyze the spot welding process using the MSc MOHAMED software. And the second one is to investigate how electrical and thermal conductivity could affect the formation of the weld nugget. Next, this study focused on the formation of the weld nugget on the S235 steel sheet based on several variables that have been mentioned before, that is the 6 parameters. So the limitation for this research is to determine the quality of the welds and durability of the electrodes. It is because there is not much previous research on this resistance spot welding. The resistance spot welding is quite complicated because it required an analysis on the thermal, electrical, mechanical analysis, temperature distribution in both electrodes and also the materials. For the methodology, there are 7 methodology altogether used to complete this research. The first one is aim, which the aim is to a study on the electrical and thermal conductivity to S235 steel sheet on spot weld. The second one is reviewing the literature to get a better understanding on what is electrical and thermal. The third one is the selection of material. The material select for this research is S235 steel sheet, which is commonly used in structural industry. Next is parameters. There are 6 parameters that need to be defined first before starting the simulation. The simulation software used is MSc MOHAMED, and the 6th one is to analyze the data, which is what temperature is the weld nugget from, and the last one is writing the result. And finally, this is the expected result from the simulation of the resistance spot welding. So as the conclusion that get from the simulation, the optimum temperature needed for the formation of the weld nugget must be around 1000 degrees Celsius and above. It is because the melting point of the material S235 is around 1400 to 1500. So the temperature needed for the resistance spot welding to be successfully have the weld nugget is it must achieve a temperature above 1 degree Celsius. So this is all for my presentation. Thank you for lending your eyes and ears.